Hi, here we are discussing interference. So, first of all, we have to define what is superposition of waves. Superposition means displacement produced by a number of waves is the vector sum of the displacements produced by each of the waves. That is called uh, superposition of waves. So when we consider superposition of waves, here we are dealing with two sources S1 and S2 which is at a distance S1p and S2p from those sources. So we can say that S1p is equal to S2p. So we can say that the distance traveled by each waves to the point P is same. So when we write the displacement equation, the displacement produced by the source S1 is y1 is equal to a cos omega t. Displacement produced by the source S2 is equal to y2 is equal to a cos omega t. So when you write this displacement, you can find the resultant displacement y is equal to y1 plus y2 is equal to 2a cos omega t. So this is the displacement equation of this work. So in this case we discuss coherent sources. Why we are calling this as a coherent source means at a particular point the phase difference between displacements produced by each of the waves does not change with the time, then we can say that these are all coherent sources. So the phase difference between the displacement does not change with the time. That is the condition for a coherent source. So we say that a cos omega t is the phase difference. It is the displacement in first equation. It is y2 a cos omega t in the second equation. So that is actually y2 y1, but it is wrongly mentioned as y2. Just forgive me. Okay, so we can say that y is equal to y1 plus y2 is equal to 2a cos omega t. Here, the resultant displacement has a amplitude 2a, which is 2 times the initial case. So this is our interference pattern or the resultant interference. So we can say that our wave at that particular point add constructively, or we can say that it is 2a into cos omega t. So the sign pattern remains the same, but the displacement it doubles the initial case. So in this case we can say that here this happens only when S1p is equal to S2p. From source S1 to P is same and S2 to P is same. Okay, so that is the sole condition of this one. Here when we add this sources, what is the displacement means, we can say that it is y is equal to y1 plus it is 2a cos omega t. So in that case initially we can say that the intensity of the initial wave is I is equal to a square, is proportional to a square, square of the amplitude, and in the final case we can say that intensity is proportional to 2a whole square, that is 4a square. So if we consider I0 as the initial intensity, that is a square, so we can write that now the intensity changes to I is equal to 4I0. 4I0 means 4a square. So the intensity changes, so we can see a more brightness at this spot. So that is the idea of interference. When we consider these points, we can say that the perpendicular bisector of S1 and S2 shows this point and shows this kind of interference. And we can say that the two sources that are interfere like this, we can say that these are all constructive interference, so that we get a more brighter spot or more intenser spot than the initial one. When we consider second point q, here S1q is equal to 7 lambda and S2q is equal to 9 lambda. the path difference is 2 lambda, and we can write y1 is equal to a cos omega t and y2 is equal to a cos omega t minus 4 pi, which means it has a phase difference of 4 pi, because lambda, if there is a lambda path difference, we can say that it corresponds to 2 pi phase difference. If it is 2 lambda phase difference, path difference, means we can say that that is 4 pi phase difference. That is why a 4 pi comes here. So it again a cos omega t minus 4 pi is equal to a cos omega t. Here you can say that it is a cos omega t again. So again it is constructive, constructively interfere, or we can say that this is a constructive interference example. So both these points, first point and second point, shows the point where we have a constructive interference. So in this case we can say that the waves are in phase with each other, they are in the same phase, and they add up like that, so that we get a more brighter intensity, very much intensity spot. That's all. At this point we are considering a point R where the path difference is 9.75 lambda, and S2R is the path traveled by the second source wave is 7.25 lambda. So the path difference is S2R minus S1R, that is equal to minus 2.5 lambda. So when we write the displacement, you can write y1 is equal to a cos omega t, and the displacement s2 is equal to y2 is equal to a cos omega t plus 5 pi. Why it is a 5 pi means we can say that when there is a lambda path difference, that is corresponding to 2 pi wave, a 2 pi phase difference. When there is a 2 lambda path difference, means this corresponds to 4 pi. And we can say that when there is a 0.5, 0.5 means 2.5 lambda, that corresponds to a 2 pi by 2, that means pi phase difference. So for 2 pi plus 2 pi plus pi, so altogether we can say that that is a 5 pi phase difference. That is why it is a 5 pi phase difference, that again minus a cos omega t. So when we find the resultant displacement, we get a cos omega t minus a cos omega t, that is equal to 0. So that is a place where we can see a zero intensity spot. So here we do not see anything, it is a dark spot. So we can say that the waves are destructively interfere in this space. So it is a destructive interference. So in this case we consider constructive and destructive interference spots.